Hi, in this video, I'll show you a few basic tools for creating 3D solids in Plasticity using this simple example. I'll start a new project. Here we will begin by creating a circle. Select the Circle Drawing tool and specify the center point at the origin of the coordinate system. As you can see, a snap appeared here. If we click at this point, the center of the circle will be linked to the origin of the coordinate system. Now, if you would like to get a circle with a specific diameter, you need to press the Tab key, and we can enter a specific value here. I'll type 100, and to confirm it, I press Enter key. In this way, we created a circle with a diameter of 100 millimeters. Now I will switch to the top view and would like to create another circle. This time it will be a circle with a diameter of 9 millimeters, but I want to create this circle in such a way that the center of this circle will be on the y-axis and the circle will be offset from the origin of the coordinate system by 40 millimeters. If I select the Circle Drawing tool, I can easily place the circle on the y-axis. Because when I hover over the y-axis, a snap appeared here. If I click the left mouse button, the center of the circle will lie on the axis. However, in this case, I cannot easily add a dimension from the origin of the coordinate system, so I will do it in such a way that the center of this circle is also placed at the origin of the coordinate system. I click the left mouse button, now I press Tab and enter 9, then I press Enter to confirm. Now this circle is selected, and I select the Move command. I move this circle along the y-axis by 40 millimeters. We can do it by typing 40 here, or we can press Y key on the keyboard and enter 40, then press Enter to confirm. I would like to create 10 of these circles evenly spaced within this larger circle. To do this, I use the Radial Array command. This geometry is selected, so I choose the Radial Array command. Now I define the center point of the radial array, which is the point relative to which the radial array will be performed. I click the left mouse button and specify the number of elements. We enter 10 and click OK. In this way, we created 10 such circles. Now I will choose the Circle Drawing tool once again and draw another circle whose center will lie at the origin of the coordinate system. The diameter of the circle is 40 millimeters, and I press Enter to confirm. Now I will turn off the view of this plane, and based on this geometry, we will add an extrusion. I would like to add the extrusion based on this area. To be able to select areas, we need to turn on this icon. We can do this by clicking here with the left mouse button, or we can press the 3 key on the keyboard. Regarding the geometry we created, they are listed here in this window. I have the geometry list collapsed here, but as you can see, all the geometries we created are appearing. So after selecting the area, the Extrude command is automatically activated. That's what I care about. Now to add an extrusion of this area, we can drag it. However, here, as you can see, when adding an extrusion in this way, it is hard to add an extrusion to a specific value. But we can press the D key on the keyboard and enter the extrusion value. I pressed D, entered 10, and in this way, an extrusion of 10 millimeters was performed. By the way, here, commands that may be useful during the currently performed operation appear. For now, we accept this. I click OK, and we have added the extrusion. A solid has formed here, and we have created a solid and flat geometries. As for these flat geometries, we can delete them because they will no longer be needed. When it comes to creating 3D models in Plasticity, if we create 3D models based on flat geometries, this model is not linked to those geometries. Once we create something, it stays that way. If we change some geometry, it will not affect the model. For a moment, I will hide the model. For example, I will change the diameter of this circle. Here, as you can see, I cannot select the circle because I have area selection active. If I want to select only the circle, I need to switch to edge selection. I select the circle, and now, to change the diameter of the circle, I press the equal sign on the keyboard and type, for example, 20 here. The diameter of this circle has been changed, but as I mentioned, it has no effect on the 3D solid. This solid is now independent of those geometries, and we can delete those geometries. I select all the geometries. To delete the geometry, we simply select the geometry and press the Delete key. Okay, let's move on to creating additional parts of the solid. Now we will create kind of counterbores for these holes. I will switch to face selection. I select this face and press the spacebar. A temporary construction plane has been activated here. Now I select the circle drawing tool and draw a circle whose center aligns with the center of this circle. So here, with this snap active, I click the left mouse button. Now I press Tab key to specify the diameter of this circle and enter 15 here. Now I will hide this plane, and this circle has been created in such a way. Based on this circle, we will also create a radial array. The circle is selected. I choose the radial array command, and as the center of the radial array, I select this point or this point. In this case, it doesn't matter. It is important to select a point that aligns with the z-axis. I click the left mouse button, and here specify the number of elements by entering 10 and clicking OK. Now all these circles are already selected. In this case, if we add the extrude command, which is under this icon, or we can invoke it by pressing the E key on the keyboard, if I pull gently, the extrusion will be added in this way because the edges are selected, not areas. Therefore, we will cancel this and deselect the selection we have selected. So we could select all these holes by holding down the Shift key. I just press the Shift key and select these areas. However, if there were many more areas, selecting them might be time-consuming. When it comes to selecting geometries, we can also do this using the selection window. In this case, all the faces will be selected, but we can do it in such a way that we temporarily turn off the visibility of the solid. We press the left mouse button and drag over all the areas. At this point, we can turn on the visibility of the solid and add the another holes. To add a hole, we need to specify a negative value. We can also drag it down or simply press the D key and enter minus so that this extrusion is added downwards. However, at this point, if I accept this, new solids will be created. If I turn off the visibility of this solid, it will look like this. We could use the operation of subtracting one solid from another. However, we can do that at the extrusion creation stage. Now I press Ctrl Z to return to that stage. If I drag down, press D, and enter -5. At this point, we have the difference command. We can immediately perform a Boolean operation based on which this extrusion we are currently creating will be cut out from this solid. I press the W key on the keyboard, and now I need to specify the solid from which these extrusion will be removed. I click on this solid. In the preview, you can already see what it will look like. I click OK to accept it. In this way, we created counterbore holes. Here, as you can see, we also have the geometry of the holes. These geometries will no longer be needed. I click the left mouse button on the first one, press Shift, click on the last one, and press Delete to remove these geometries. Now we will create another part of this solid, and I will show you another interesting operation in Plasticity. I will switch to Edge Selection, select this edge, and press the O key on the keyboard to activate the Offset command. Now, by dragging, I can specify the offset, and here I would like to add an offset of -5 millimeters to create something like this. I press the D key on the keyboard, enter -5, and press Enter to confirm. We have created an offset of this edge by 5 millimeters in this direction. Now I switch to Area Selection. I click the left mouse button here, and now based on this area, I can add another extrusion. I press the D key and enter 75 here. I press Enter to confirm. Now I press Escape to cancel this command, and we have created something like this. Now we will move on to adding chamfers and fillets. When it comes to adding chamfers and fillets, we add them based on edges, so I will switch to Edge Selection. I select the edges on which I would like to add a chamfer or fillet. Holding down the Shift key, I select these two edges. Now, if I drag one way, a fillet will be created. If I drag the other way, a chamfer will be created. However, here, if we pay attention to the available commands, we have something like chamfer distance. If I press the C key and enter 1, a chamfer of size 1 millimeter will be created. Press Enter to confirm, and enter again to finish this command. Now, I will select this edge and add a radius of 5 millimeters. So I dragged in this direction to create some radius. I press D, enter 5, press Enter, and enter again, and we created the radius. Next, I would like to add chamfers to the outer edge of this solid and to all edges of these holes. To do this easily, I switch to Area Selection, select this area, and now I would like to convert this selection from Area Selection to Edge Selection, so that the edges are selected based on this area. We can do this easily. Just use the keyboard shortcut Ctrl+2, and the selection has been converted to Edge Selection. Now we can press the C key, 1, and press Enter to confirm. In this way, we have added chamfers to all edges of this wall. And here, even though this edge was selected, a chamfer was not added. That's what I meant. I didn't want any chamfer here, so it looks good. If in the future, in the case of such a selection, you want to deselect some edges, you can easily do this. Just press the Control key and deselect the selected edges. However, in this case, you must switch to Edge Selection mode. I'll show you this in the next example, where we will create a similar part, but in a slightly different way. Create a new project. You can create a new project, or you can open a new Plasticity window. And now we will create this part in a slightly different way. We will do it using the Revolve command, which creates a solid by rotating a 2D sketch around a specified axis. In this case, we will create a sketch on the XZ plane. Select this plane, and we will start by drawing a line. Place the beginning of the line at the origin of the coordinate system, and now draw a line that is 50 millimeters long. To do this, press the Tab key and type 50. Now the length of this line is locked, and we can change the angle here. If you press Tab, we will switch to defining the angle, and we need to specify an angle. However, I will press Tab again and align this line along the x-axis. Now if you press Enter, the line drawing will be completed. If we want to create another segment of this solid, we need to select the Line Drawing command again and start drawing the line from this point. I click here, drag a bit upwards, press Tab, type 10, and this time, instead of pressing Enter, I click the left mouse button. In this way, I have confirmed the length of this line, but I have not canceled the Line Drawing command, and I can create another line. This time I will drag this line in this direction. I would like this line to be horizontal, but some snap has been activated, so it is difficult for me to set this line perfectly horizontal. We will do this by defining the angle. I press Tab and type 20 for the length of this line. I press Tab and type 90 for the angle, and then I click the left mouse button to finish drawing the line here. Next segment of the line. Drag a bit upwards, press Tab, type 75, and click the left mouse button to finish drawing the line. Now I drag a bit this way, press Tab, type 10, left mouse button. I will finish this line on this line, so given that this snap is active, I click the left mouse button. Now right-click to finish the line drawing. In this way, we have created a sketch, based on which we will create a solid by rotating this sketch around a specified axis. Here we can also remove this segment of the line. Let's select the Trim command and click here, and this line has been removed. Right-click to cancel this command and close the view of this plane. Based on this area, we will create a solid by rotating this area around a specified axis. I select this area and choose the Revolve command. We need to define the axis around which we will rotate this sketch. We define the axis by indicating 2 points. For the first point, select the origin of the coordinate system, and for the second point, select any point lying on the z-axis. Just click the left mouse button when this snap is active. In this way, we have created this solid. Click OK, and we can proceed to create the next fragments of the geometry. Let's turn off the visibility of these geometries. Select the face selection, select this face, and press the spacebar on the keyboard to activate a temporary construction plane. Here we will also create holes, but we will approach this in a slightly different way. Select Circle Drawing and draw a circle with a diameter of 9 millimeters, with the center point at the origin of the coordinate system. Press Tab, 9, Enter, and we have created such a circle. I will turn off the visibility of this plane, and here we have the circle. Select this area and add a downward extrusion. I would like to add an extrusion to this face, and we can do it easily. When we have the extrusion active, we can press the Control key. The snaps will be activated. Now, when you hover over some geometry on the bottom face of this model, the extrusion will be executed to that value. Release the left mouse button, and the extrusion has been made to the bottom face of this solid. I click OK to confirm this. Now I will turn off the visibility of this solid. We will create another circle. We can also turn off the visibility of this circle. Select the circle drawing and place the center of the circle at the center of the top face of this cylinder. Tab, enter 15, press the Enter key, and add a downward extrusion, so I press D, enter -5, press Enter. Before we confirm this, I would like this extrusion that we create to be connected immediately with this solid with this smaller cylinder. We have the Union command. If we press the Q key on the keyboard, we can point to this solid. Now those two solids will be combined into one solid. Click OK to confirm this, and we have something like this. Now I will move this solid by 40 millimeters along the y-axis. We select the Move command or press the G key on the keyboard. Then I press Y and type 40, press Enter, and Enter again. This solid has already been moved. Turn off the visibility of this circle and turn on the visibility of this solid. Now, based on this solid, we will create a circular array. This solid is selected. Select the Radial Array command. Define the center of the circular pattern and enter the number of elements. Here we add 10 elements and click OK. In this way, we created 10 such solids. Now we will add a Boolean operation, based on which we will subtract these solids from the larger solid. To do this, we need to highlight the larger solid and these smaller solids. However, in this case, if we want to subtract from this solid must be selected first. I select this solid in the operation tree. And we can do it in such a way that I press the Shift key and click on the last solid. In this way, all will be selected. Now select the Boolean operation. We can click this icon or press the Q key on the keyboard. By default, the difference operation is applied, which subtracts the selected solids from the first solid. Accept this, and in this way, and this solid has been created. Here, as you can see in the case of this operation, the solids based on which holes were made have been removed and are no longer available. If you would like these solids to remain in the project, we can do this in a slightly different way. I press Ctrl-Z to get back to this moment. I select this solid. I press Shift and click on the last one to select the remaining solids. I press the Q key. Here we have this stage where these smaller solids will be cut from the larger solid. If we click OK, these smaller solids will be removed. And if you would like to keep them, we click this Keep Tools button or press the T key on the keyboard and click OK. Now these solids have remained in the project. It might seem that nothing has changed, but if I now turn off the visibility of these solids, select these solids, and press the H key on the keyboard, then these solids have been removed from the larger solid. If you would like to add chamfers and fillets, we do it as in the previous example. Select the edges. Here, with the Shift key, I select these two edges, press the C key, press 1 key, press Enter, and we've added chamfers. I accept this with the right mouse button. Now I will add a radius here. Here I will add a slightly smaller radius, D1. Okay, enter. I select face selection and select this face. I press Ctrl+2, and the selection has been switched to edge selection. Now, to deselect this edge, I switch to edge selection mode. Press the Ctrl key and click on this edge. This edge has already been deselected. To add a chamfer to these edges, I press C key, press 1 key, press Enter and Enter again, and in this way, we have created this solid. In both the first and the second example, we created similar solids. However, in both examples, we used different methods of creating 3D solids. The operations for creating 3D solids that I presented to you in this tutorial are the basic operations for creating 3D solids in 3D CAD systems. Thanks for watching. Please subscribe to this channel.